Hey everybody, this is Larry. This is day 6 of the Leetcode daily challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. I'm in the airport right now in Medellin, and I'm going back to New York, but I have maybe an hour to the flight, so hopefully I'll finish this problem. But yeah, let me know what you think and hit all the buttons or whatever. Today's problem is 1359, count all valid pickup and delivery options, and it's a hard problem. Okay, so hopefully I get to finish this, otherwise I have to finish when I get home. Okay, so there's a mod, so let's get that. So I forget that a lot, so let's get that into the place. And then maybe something like this. Okay, so what do? Count all valid pickup possible such as delivery. Okay. Wow. The first thing that I would say about these problems is that usually I will not brute force, but well, maybe brute force if I have to, but I would like using pen and paper manually create the first few. And then kind of see if I could feel a pattern. Sometimes I will also brute force just to see a pattern, but you can see that this actually grows really fast from 1 to 6 to 90. There is also a website called OGIS, so you can kind of look that up, but I'm not going to do that because you didn't watch this video as so that someone could tell you to Google or something, right? So I hope not anyway. I don't know. But anyway, I'm going to challenge myself. So okay, so let's start with n is equal. So n equals, okay, n is equal to 1. There's only one case, which is, I don't know how, I guess the same notation they do, right? Then n is equal to 2. So then, okay, so then that means that you take the previous thing, and the previous thing had 2 items, right? This is almost like dynamic programming or memorization, but now I'm doing it bottoms up, but manually, and try to figure out the logic. So here, so let's say you have 2 items, right? So then now, how many places you can put the pickup? That means that you can pick up in 3 places, right? Yeah, and then, well, and then the drop off. If you put the pickup here, then you have 1, 2, 3 places. Yeah, so then that means that there's 3 plus, and then let's say we put the pickup here, then we have 2, right? So that's 3 plus 2 plus 1. You can kind of extrapolate a little bit. For example, if we have P and a D here, then that's 3 plus 2 plus 1, right? Okay. And of course, this is going to be 6, and that's 6 times f of 1, because, well, in this case, it doesn't matter because there's only one example, so this is 6, which matches. So then n is equal to 3 means that you have 4 of these, right? And then now you have, let's say we have put P here, then 1, 2, 3, 4, 5, plus 4, plus 3, plus 2, plus 1. So that's, I don't know what that is, right? That's 15 times f of 2, because for here, one of every x you can, there are 6 different ways to do this thing, right? So that means that there's 6 different ways of having these x's. If you want to say that, like fill it in the x's, and because there's 6 different ways, then you have 15 ways to kind of put in the new ones on each of those 6. So that's why you have 15 times 6 is equal to 90. So I think this, so I think now we have a good idea. I don't know if it's a good idea, but we have an idea to play with. We can kind of even try it out for wait, yeah. So we have 4 things, so you have 6 prior things, right? So this is going to be, let's say we have put P here, then you have 1, 2, 3, 4, 5, 6, 7. So 7 plus 6 plus 5 dot plus dot 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 plus 1. So that's what? I'm always bad at this actually. Is it 36 times 21? No, it's the other way. 56, 28, right? Is that right? I always, so that's 5, yeah, okay, I think this is right. 7 times 8 over 2, right? Is the idea. I always forget if it's plus 1 or minus 1 over 2. That's why I always mix them up, not gonna lie. So this after equals 3 is equal to 28 times 90, which is equal to, I'm just plugging in the calculator now that I could do in my head, 20, right? And of course, You should be able to verify this, but I am going to cheat a little bit and just run the code. This will actually give me wrong answer, or not compile, so we have to run it again. But if this is right, then I think we have a good pattern, and it seems like that's correct, right? So then now we can play around with how to generate this sequence, right? So answer is equal to 0, and then now we have let's see, or maybe answer is equal to 1. How do I want to say it? I mean, we can do the constant way, and then now for I is in range from maybe 1 to n plus 1, n plus 1 being exclusive bound, of course, or maybe start at 2. Yeah, maybe start at 2 because 1 is just 1, right? And then now, what is this? So 2 means that 2 means that the previous number is 1, so I minus 1, right? Because for example 3 is, we get 2 times 2, so this is times 2 times this, right? And then now you have this plus 1 is the number of gaps, right? Okay, so let's put it backwards. Previous, let's just call previous number of barriers, or you know, like in a thing. So yeah, previous. Okay, let's go previous, right? And then now you have pickup possibility is equal to previous plus 1, because that's just the number of gaps. Oh yeah, the number of spaces you can put the pickup. Right, like for example here you can put 1, 2, 3, 4, 5, so that's just previous plus 1, and then after that the drop off, the total drop off, the total is equal to pickup times pickup plus 1 over 2, right? So that's this part, and then that is of course times the previous answer. So, and in this case that means answer is equal to answer. I mean, you can okay, I'll try to make this a little bit clearer, right? So next, current is equal to the answer is like technically the previous number. We can extend it to an array if you like, but times total, and then at very end answer is equal to current, right? Of course I probably should do more mod math here, so let's do that here. I think this is a good place for it. Yeah, let's give it a spin. I think this is maybe right. Oh, I didn't do n. Oh, this is just small n. Okay, big n. Oh, that looks good. And of course, let's try for some bigger numbers. But I would say this problem is a very combinatorial, very mathy problem. This looks good for random numbers, so let's give it a submit, unless I do something weird. So definitely, oh, that was the first time I solved this. 705-day streak from the airport and met it in. So yeah, this is obviously going to be linear time, linear in the size of n, but technically exponential in the size of the input. So yeah, because n is, you know, number of bits and stuff like that, and of course space is going to be just technically constant, technically linear, depending on how you want to say it, depending on the size of the input, which is a number, of course. The mod will bound it by 32 bits or whatever, right? In this case, maybe 31 bits, but same idea. Yeah, so this is a combinatorial problem, and I don't know that I don't think this will show up on an interview, to be honest, but it is a good fun problem if you like combinatorics or math or something like that. Cool. I think that's all I have for this one. I'm in the airport after all, so I'll see you later. Stay good, stay healthy, take good mental health. Take care. Bye-bye.